Today we will know the fantastic B1, its history, characteristics, and technical data. Don't forget to subscribe to the channel, share, like, and comment. Your suggestion is important. Thank us for watching and welcome on board. The world was divided, and tensions between superpowers shaped military technology. In this context, the need arose for a strategic bomber with speed, range, and deep penetration capability. The B1 Lancer was conceived to cross hostile borders, fly low and fast, and deliver its payload with devastating precision. Initially envisioned in the 1970s, the project faced cancellations, criticisms, and revivals. It wasn't just an aircraft, but a response to nuclear doctrine and the evolution of enemy defense systems. With variable geometry wings and powerful engines, the B1 combined maneuverability and payload capacity like no other bomber of its time. Its aggressive silhouette and stealth profile marked a new era. Even before flying in combat, the Lancer was already a symbol of deterrence, a swift shadow in the Cold War sky. The concept of movable wings completely transformed the aircraft performance. At subsonic speeds, extended wings provided optimal lift and maneuverability. When swept back, they reduced drag and allowed supersonic flight. This variable geometry offered the B1 Lancer unprecedented flexibility. It could take off with a heavy payload, fly low to avoid radar, and accelerate when necessary. The technology required precise engineering, reliable hydraulic actuators, and sensors integrated into the flight control system. Each wing movement was carefully calculated to maintain stability and efficiency. It wasn't just an aesthetic innovation, but a real solution to the dilemma between agility and range. The Lancer could adapt to the operational environment in real time, transforming according to mission demands. It was a bomber that defied traditional category limits. For General Electric G102 turbofan engines propelled the B1 Lancer to speeds exceeding Mach 1.2 more than speed. These engines provided reliability and power in all flight phases, integrated with adjustable air intakes. They optimized performance at both low altitude and high cruise. Each unit produced about 30,000 pounds of thrust with afterburner, allowing the bomber to quickly escape hostile zones or reach distant targets with agility. The engineering involved required thermal management systems, vibration monitoring, and electrical redundancy. Propulsion was more than force. It was autonomy, versatility, and responsiveness. Even with its large size, the B1 behaved like a swift hunter. The harmony between weight, aerodynamics, and power defined its strategic superiority. The roar of the engines was a warning signal for any enemy radar. On board the B1, electronic technology was an accessory, but the mission's brain. The inertial navigation system, complemented by GPS and terrain-following radar, allowed flights at extremely low altitudes, avoiding detection. Advanced avionics controlled everything from encrypted communication to guided weaponry. Multifunctional panels, threat sensors, and mission computers worked together, providing the crew with total situational awareness. The modular architecture facilitated updates, keeping the Lancer technologically relevant over the decades. System integration was critical. Any failure could compromise the entire mission. With efficient electronic support, the bomber flew silently under enemy eyes, ready to act with surgical precision. In the B1, combat wasn't won just with bombs or with bites. The sky was its domain and information its weapon. Versatility defines the B1 weapons bay. With the capacity to carry up to 34 tons of armament, the bomber can operate with missiles, guided bombs, conventional or nuclear warheads. 3 internal bays optimize weight distribution and reduce drag. This arrangement allows sequential precision launches with devastating impact. Unlike its predecessors, the B1 stood out for its flexibility in conventional war theaters, especially after the Cold War ended. With modern updates, it began integrating smart bombs like dams, becoming a key player in surgical missions. Its payload capacity isn't just quantitative but strategic. The Lancer can carry multiple types of armament in a single mission, adapting to different targets. It doesn't just carry bombs. It conveys a message of technological superiority and global deterrence. The B-1 houses a crew of 4, 2 pilots and 2 weapon systems officers. Each position is essential for mission success. The cockpit was designed for long flight hours, with ergonomic controls and easy-to-read instruments. Pilots operate the aircraft with the aid of digital and analog commands, while the officers monitor sensors, plan attacks, and respond to threats. Synchronization among crew members is vital. There's no room for error in a strategic bomber. Internal communication systems and automated support assist in the flow of quick decisions. The cockpit is shielded against electromagnetic interference and has protection against nuclear weapons if necessary. More than operators, the crew members are managers of a complex machine. Inside the cockpit, focus is absolute. Every button has a purpose. Every action, a consequence. Unlike traditional bombers that operate at high altitudes, the B-1 was designed to fly close to the ground. The reason? To avoid detection by enemy radars. Equipped with terrain-following radar, it automatically adjusts its altitude, navigating around mountains and valleys at high speed. This ability allows it to penetrate deep into hostile territory undetected. Flying at this regime is challenging, requiring extreme precision from the systems and crew attention. Low-level flight at subsonic or transonic speeds reduces the chances of interception by fighters or surface-to-air missiles. It's a dance between terrain and stealth. Each mission executed in this profile requires meticulous planning and detailed geographic knowledge. The B-1 isn't just an attack vector. It's a master of evasion. Its strength lies in silent movement among the terrain shadows. After the initial cancellation of the B-1A, the program was restructured in the 1980s, resulting in the B-1B. This new version incorporated substantial improvements in stealth avionics and structural resistance. The maximum speed was limited to enhance low-altitude performance and extend airframe durability. The fuselage received radar-absorbent materials, significantly reducing its signature on enemy defense systems. The B-1B began operating not only as a nuclear bomber, but also in conventional roles, expanding its tactical spectrum. The program faced criticism for its high cost, but proved its value with reliable performance in real missions. Continuous evolution through modernization packages ensured its relevance. From a Cold War symbol, the Lancer became a key player in 21st century conflicts. Adapting over time became its greatest weapon. The B-1B was extensively used in conflicts such as Afghanistan, Iraq, Syria, and Kosovo. Its combination of range, speed, and armament capacity made it an ideal platform for precision attacks. Missions lasting 10, 15, or even 20 hours were not uncommon, with aerial refueling and real-time target reprogramming. In combat, the Lancer acted as a flying arsenal, supporting ground troops with guided bombs and strategic surveillance. Its constant presence in the theater of operations commanded respect. Unlike short-range fighters, the B-1B could remain in the conflict zone for extended periods, offering continuous coverage. The robustness of its systems, mechanical reliability, and crew training ensured its reputation. In the field, it wasn't just another plane. It was a hammer from the sky, ready to strike with precision wherever necessary. Operating a machine like the B-1 requires a sophisticated maintenance structure. Each flight is followed by rigorous inspections, especially on hydraulic systems, engines, movable wings, and onboard electronics. Ground teams need specialized training and dedicated equipment. The average time between overhauls varies depending on the mission profile. Predictive maintenance, based on sensors and digital histories, reduces failures and optimizes availability. The movable wing system, in particular, requires continuous attention, with actuation tests and structural verification. Logistics involve complex spare parts and direct technical support from the industry. In hostile environments, mobile hangars and specialized trailers ensure operational readiness. Without the maintenance chain, the B-1 doesn't take off. Air power begins on the ground, and keeping the Lancer ready is as critical a mission as deploying it in combat. The B-1 autonomy is significantly extended with aerial refueling. Equipped with a receptacle system, it can connect a tanker aircraft and replenish its tanks without landing. This capability allows it to cover great distances, cross oceans, or remain for hours in strategic areas. Refueling maneuvers require extreme piloting precision, especially in adverse weather conditions or at night. Coordination with the tanker aircraft is essential for success. With this capability, the Lancer becomes truly global. It can take off from bases in the United States and reach any point on the planet with just a few aerial connections. In joint operations, refueling allows rapid response to crises and flexible tactical deployment. Range is no longer limited to the initial fuel load, but to planning and coordinated execution. The sky ceases to be an obstacle and becomes a bridge. Even after decades of service, the B-1B remains operational thanks to modernization programs. New communication systems, more precise sensors, updated avionics, and integration of modern armaments maintain its effectiveness. The U.S. Air Force explores its potential as a launch platform for hypersonic missiles. Operational longevity depends on the balance between maintenance, innovation, and adaptation. Although the B-21 Raider represents the future of strategic aviation, the B-1 remains relevant. Its payload capacity remains unmatched. Current doctrine values versatile and reliable platforms, and the Lancer still delivers both. The years have passed, but the project has demonstrated resilience and the ability to evolve. More than a relic, the B-1 is a living symbol of persistent engineering. Its shadow will continue to cross the sky longer than many imagined. The B-1 represents more than an aircraft. It's a synthesis of technology, strategy, and adaptability, created in a bipolar world. It survived obsolescence with technical intelligence and military planning. Its real missions prove its value. Its structure, designed for speed and payload, will serve as a reference for future generations of bombers. The concept of aerodynamic flexibility, combined with intelligent avionics and diversified armament, redefine the role of bombers in modern warfare. Even upon retiring, the B-1 won't be forgotten. Its legacy is that a machine created to deter, adapted to win, and maintain with pride. A true supersonic warrior that spanned decades and scenarios, defying time and the logic of retirement. In the wake of its engines remains the echo of its mission,